myself Nikhil Nagar, and today lectures our task is to design a transmission tower. How to model and how to design a transmission tower. That is our task for the today class. So first we create our model by the file name of transmission tower, and the units are in metric and create. So today the transmission tower. Why we use the transmission tower? Transmission tower are the structure which holds the wires, electric wires that you can see in your cities also. The high voltage wires, these are hold that wires. So we have to design this part also as a structural engineer. So let's start. How to first we have to model our geometry. How to make our geometry for the transmission tower. It is also a very difficult part of this project. So now first we have to go the grid and take a beam grid. Beam grid, as it we can change our view is top view, and the plane should be exact plane of the grid. So we have to click on edit, and plane is exact, and all things are okay. Now click on OK. So just see what I am doing. I am creating a 10 meter by 10 meter square, and then click on escape. Now again, to draw any other beam, we have to click on snap beam, and I create again a 8 meter by 8 meter square. Now click on escape, and again 4 meter, 2 meter by a 2 meter. No, it's wrong. Control Z to go backward. Snap node 2 meter by a 2 meter, and same in another thing we can create these 4 meter by 4 meter, 8 meter by 8 meter, and click on escape. Again this square also we have to form. Now click on escape. You can see this type of figure that we have make. So now click on close. So the grid is off. Now we can see our structure in isometric view. Click on view, go to the isometric. As you can see, your whole structure is in a single plane. Now we have to translate, and we have to move in upper direction these plane one by one. Just like I click my view, change my view in top view, and select the middle these four frames, and click on right click on the window and click on move F2. Click on move, and in the y direction we have to place at like 5 meter we can take. Click on OK. Click on yes. Now I change my view again as isometric. So you can see this all the structure is up at the height of 5 meter below the this frame. So as well as we have to move these sides also by this same way. So change our view and select middle of the three squares, and click on F. Click on right click on your window and click on move. Again y direction +5. Click on OK. Click on S. Again middle two squares we have to move. F2. Again 5 meter. Click on yes. Now our middle one, move it by the right click on the window with 5 meter height in the wide axis. So now the all are at their different levels, you can see. So now we have to join these all the nodes. So we can use our again top view, and for the join we have to use add beam command. So click on add beam and join these. Okay. I suggest you that we don't draw for each corner, each diagonal, because it will take a lot of time. So we use a trick. First, I go to the select and click on node cursor and select this node. We have select this node, so we have to copy paste this node. Control plus C and then Control plus V. Then I want to this node at the center point at here, because this dimension is 2 meter and this vertical dimension is also 2 meter. So this is 1 meter and 1 meter below. So 1 meter right side means in x direction, positive x direction, 1 meter we have to move, and in below means in z direction, positive z direction, we have to move by 1 meter also here, and then click on OK. So as you can see, this node is copied here. So we have to use this node by which command I will tell you again. So go to the geometry. Now we have to use the circular repeat. Click on circular repeat. Axis of rotation in vertical direction means y direction. How many steps? 360 degree. 1, 2, 3, 4. We have to take 4 steps and select the node by which we have to rotate. This node selected. We don't have to use link steps because these are already links. So click on OK. Oh, we didn't select the members. So first we have to select these members. Press here and hold the control and select these 4 members. Now go to the circular repeat and 360 degree axis rotation by number of steps 4, axis rotation at this node didn't lock, and OK. So you can see this is a shortest way and a trick how to use our circular command. So now we change our view isometric. So you can see these are connected. So change our view, and if you want to delete this node, so you can it go to the select, use node cursor and select this node and click on the delete. Now we go to the our next part. So change our view. See, we want to circular a transitional repeat in y direction up to the views up to it. Number of steps we can give as like 6, and give the height and 3 meters, link by yes, and in the y direction. So we repeat in the y direction up to the 333 6 times of 18 meters, 18 meter, and link it and click on OK. So it will be copied here, as you can see. Now we change our view, isometric view. Now we have to give a gap here because at the center there is a cone surface. So you have to give a cone top node. That's the same procedure. We have to select a copy. We have to select a node and copy paste it. Then Control C and Control V. So this is 2 meter length. So in the x direction we have to go 1 meter. In the z direction we have to go 1 meter. And for example, in the y direction we take 1.5 meter. So click on OK. So this node is created here. Now we have to join all the members. So click on escape and go to the geometry and click on add beam. Now we add this node by the other four nodes. Now click on escape, adds, go to the 3D rendering. This is our main tower. Now we go to the assigning their bracings also. So we give the bracing add as a diagonal member. So we use simple add beam concept. Select these nodes. Here we also use the circular repeat command. I will tell you how we use, because we draw the bracings only for the one face, not for the others. In this way, we can draw and add our beams in the diagonal direction. Okay. So now we added these bracings. So now we have to select it before before give the circular command, circular repeat command. So go to the view, change our suitable view as a front view. Now you can see the bracings in simple way, and by press on control, click on center points of these bracings, by which both bracings can be selected. Press as control and select these bracings. Now change our view. These bracings are selected. Now we copy it. So go to the geometry and similarly we use circular repeat command. Axis of rotation Y for, give the axis of rotation for this node middle, and we don't use our link steps and click on. So you can see in your 3D rendering the bracings are assigned. For the check that there are no other beams are overlapped, like duplicate beams can be formed. So by the utilities and beam tools and check duplicate beam. So there is no duplicate beam here. So it is okay. And same way you can check the duplicate nodes also by giving the tolerance. Because at the base, so now we change our view as a front. There no need of any beams at the base because the fixed supports are there. So it is complete. Now we go to the give the diagonal in outer side bracings also. So we have to change our view. Click on this view and give by the right click. Yeah. So now there is a trick also to give all other properties here. So we go to the top view and select one side of this in this way, and you can deselect diagonal elements by press and control. You have to click there by control and selected these cross elements. Deselect it and change your view. This is it. So because you have to give in the upper part the wings in the outer side, so you can select these also, this part also. So select it and right click on window and go to the new view. Create a new window for the view and display in active window also. Okay, so this is your view that you have selected in other way. This is your 3D rendering of this view only. So now we have to give the wings here in the outer direction. So we have to use node cursor, click on node cursor and select this node and press Ctrl C, Ctrl V. We want to copy this node in this direction. In this direction means minus x direction. So we have to give the values also in negative and take the value as 15 meter. Click on OK. This is your node. This is the press on Control Z. So you will go to the backward command also. Now click this node again. Control C, Control V, and we will take as a minus 10 meter. Click on OK, and then by the escape button. And we have to use this also. This node we have to copy at same distance, but in the plus x direction by pressing Ctrl C, Ctrl V. How much? 10 meter. Same. This is okay. Now go to the escape. Click on escape button and go to the geometry and add beam by these nodes. This node and this node, this node and this node, and add by a diagonally also in this way. Okay. By click on escape, remove it. Now select these four beams by control and click on these beams and give the nodes insert. So click on insert node. How many nodes you want to give? So I want to give like 5 nodes there. So click on 5 and click on OK. So five nodes are inserted between each beam. And now we use the add beam command, and by right click you can change your view also, and by the view tab you can take your front view also. This is our bracings that are given. So add these nodes by add beam command, and you don't need to this way by in right side also. We can copy also here. So press on control and select these bracings by clicking on cross point. So this member is at very minimum distance, so we have to select in by zoom. Press on control and this cross. Okay. So these members are selected. So easy. We have to use only the mirror command. So go to the mirror and we have to give the plane at which node. The node is in this plane. What is the plane? Plane is YZ. Vertical direction will show YZ. So YZ and give the node at which the node plane will be put. So this node I select and copy and then so you can see this all the geometry will copy here and click on escape. Now change our view and isometric. So this is our one face only because we have to give it in another side also. Okay, so there was a wrong thing also. These members are collected in diagonal because it's not our mistake, it's a software mistake that we have to understand in our mind. So you have to simply click on delete and OK and give the add beam again for here to here and from here to this node. And soon as you see these two beams are also outside the plane. So select these beams and press on control and select this beam also and delete. Same way add beam and add these beams carefully. So now these are in one plane like a 10 faces of Ravan. So you have to copy it here. So go to the top view, change your view and go to the top view and select these members. Here to here, press Ctrl, here to here. You can see which members are selected by change your view. So we have to copy these elements in backside also. So we have to copy Ctrl C, Ctrl V. Now in which direction? There is your Z direction, but we have to copy it backside, that is minus Z direction. So we have to give the value in negative and the dimension of this element is 2 meter, so that is 2. But there was a problem because we want to link these members also by the node to node, so we can't use that. So click on cancel and we have to use the translation repeat because here is the option for link steps. So click on link step and in the z direction, because in z direction but in negative, so we have to use the negative 2. Default step size is negative 2, number of steps 1, link by and then OK. So you can see this is copy here and linked also. Now we change our view, go to the view tab and take a front view. Now we have to copy it in vertical direction, that is in y. At here we want to establish it, at here we want to establish. So use same translational repeat. How many steps? 2. How many the distance? This, that is 3 meter and this is also 3 meter. So this distance is 3 to 6. So at the 6 meter spacing in the y direction, but we want to copy it in negative y direction. So we have to take this negative 6. We don't need to link by and click on OK. So these all the frames are copied here. Now we want to go over whole structure because the bottom members are also present. So go to the view tab and display whole structure. Click on that. So this is your model of transmission tower. So model of the transmission tower is complete. Now we go to the properties. So we go to the properties and we use the still sections. So we have to select, click on section database and select a still section. For the main members we take ISMB like ISHB sections. Click on Indian we take as IS MB 300 you can take, and 500 also you can take. So I take it IS MB 500. Change your material as steel 355 Newton per mm square and click on add. And for the other members that like bracings also are there. So for the bracings we have to take angle section. So click on angle and use the section of 150 150 15 and change the material still 355. Click on add and then close. Now we have to assign this material in this figure. That is a very complex task for us. So see in serious way so you can learn it in perfect manner. So we will use the view pattern. So take the front view. Now I assign this member ISMB 500. This property I assigned all these main members that are going up, or for the all cross members we assign the angle section. So select the members in that way. Select this, press on control, select this, select this, select this, and this horizontal member also. Select this member, this member, this member, and these horizontal members also are the part of ISMB 500. This member, by zoom into this you can select easily this horizontal member, this one, this one, this one member, and this one. Now select all other members also by zoom in, and the scroll button, tap on that, you can change your view. Click these members. The all the main members that in which we have to assign this main property. And select this member. These four members we have to select. This is the typical task and it will take a lot of time to assign the property. Now in the same way you have to select for this frame also. These horizontal members you can select it easily. Now the selection is complete, but behind it, this member is left. These members are selected, but behind the members we have to select also. So change our view as side view. You can see the members are left here, and the cross members are also selected, but we don't have to select these. So deselect it by the control, press on center point. Change our view, side view as, and deselect. Select this member and deselect these members. Select these object members and deselect these cross bracings. So the whole members that we want to select and assign the properties. Here the this horizontal member is remaining, this one and this one. So all the members are selected. So you can see which elements are selected in this geometry, and then properties also selected. So click on assign and assign this property also. Now we have to assign this property also. So you can choose this way, but this is take much more time. So we have to use a trick. So go to the select and click on attribute, click on missing property, and click on missing property. So these properties are not assigned for yet. So we have to assign this property to these members. So assign these members by right click. You can see which members are not assigned the property. You can see this member is unwanted because this member should have our own property. So we give it further by control button. We check out from it and assign the selfie beams, and then yes. So as we know this member is left, so we have to assign this properties. First we have to select the property and then select the member and then assign yes. Now it is complete. For check, you can check which member doesn't have any property, but it is okay. By right click and 3D rendering, you can see the 3D render view also of it. So this is our transmission tower that we have modeled. These are the frames. Click on cross. Now we go further. Click on material. So material we have assigned 375 Newton per mm square. Specification. This is a important part for the transmission tower. Specification is the what? Specification is the that if we want to tell the stat pro that this member is a like a axial member, this member is like a cable, this member is like a truss. So we have to tell the stat pro that this member is a truss member. So we have to assign a truss property, like truss property means a axial member that will take only axial and compression. So we have to add this truss member and select it, but we have to assign which property that is our ISA, means angle section. So go to specifications, click on truss member and assign these angles. So assign to certain beams and then yes. So these properties is also assigned. Now go to the supports and create a fixed support. There are two methods to create a support, by this and here fixed support is also there. So by click on add this and assign it at the support. So change your view, go to the view tab, side view, select the bottom nodes and then assign. Click on yes. The bottom nodes have the supports as fixed. Now click on escape to come out from the command. Now we go to the loading part. So loading part is important for this because the wires are go out from these nodes, these nodes, this node and this node in the outer side, and from this node and this node from in the other inner side. So we have to give the load in this way that it's match like a physical structure. So we have to select our, we don't need to give any wind definition because the wind is applied on the nodes. So we can calculate it, and if you want to give wind definition then you can give also. So click on wind definition, click on add, and code is our IS 875 part 3, and then add this and then close. Now click on wind 1 and click on add and generate our wind intensity. Code is 2015. Building type is a like a lattice tower. Height is automatically taken. Agra is you can take as Delhi. Cities you can take in Delhi. Building you can as a general building. Train category like 2. Other structure okay, and go to the lattice tower. Square cross sections, yeah, square cross sections. Member profile cross section, flat sided, rounded sided, no, we have take only flat sided. And custom we don't give any, as per the code base it will already taken. And this value for the Delhi as per IS code 0.9, 0.8 and 0.9. You can calculate it from the IS code and press enter. These intensity are all taken already. Click on add, click on close. As per the seismic definition you can give it. Click on your code is 1893 part 1 2016. Click on generate. City is Delhi. Steel building with ordinary moment resting frame. Click on it. All other building okay. Soil we can take medium. Steel MRF no. All other building you can take. And damping ratio, it is important. Damping ratio for our steel frames and steel material, that is 1%, and for the RCC frame it is equal to 5%, and for the masonry buildings it is equal to 10%. It is in our 1893 code, you can see also from there. Click on generate, add this, and for the sulfate factor 1 is also taken, add. Now we go to the load case details. As we know, the stat pro will take the earthquake log as the first. As per the stat profile programming, we have to take the earthquake loads in first number first, second at the top level. So we you have to take seismic edge and give the EQ in X direction. Click on yes and EQ in Z direction. Click on add. Third one we can take dead load DL. Click on add. Second one is live load. Give title as double M. And third one is our loading type is wind WL. Click on add. Now we give the parameters to these. Click on EQX and add a seismic load in the X direction with the factor 1. Click on add and as same in earthquake in Z direction. Seismic load Z direction factor 1 and then click on add. Now we go to the dead load. So dead load have a take selfish factor 1 close. Now there is you can see it is a question mark. So we have to assign this property to all the elements. So assign to view, assign and then yes. Because there are wires are also present, so that this load was also like a self-weight, like a dead load. So we have to assign the dead load of the wires also. So we can calculate as per the density of the wire and length of the wire, the weight, how much it will become at these nodes. So we have to take the nodal loads for these wires. So take nodal loads. Nodal loads for outer direction, that is in Z direction. So we have to take Fz equal to, like we can take 15 kilonewton the load for example, but you can calculate it. So I take a arbitrary for example value. Click on add and another one in the negative direction. Click on add. So this is our dead node. So we have to assign this at the nodes. So we have to select the nodes. So go to the select node cursor. You can see this is plus kilonewton. Plus means in the positive Z direction. So positive direction, these nodes are available in the positive Z direction. So click on control and select these nodes that are positioned in the Z direction, plus Z direction. And at the top, these are nodes we have to select and then assign to selected nodes. Assign, click on yes. So this load is assigned here. Now we have to assign this load also. So select backside nodes 1. I change my view. Click on control 1, 2, 3, 4, 5, 6. Assign this load here, but we didn't assign our load property. So first we have to assign this and click on assign to selected nodes and then assign and then click on yes. So this load is also subjected here. Now live load, what is the live? Because there is not any load will come over this structure, so there is no need only any live load here. So we can delete it also. So we delete yes. Now we assign the wind load on this structure. So click on add and go to the wind load. In which direction wind is applied? Because if the direction is this, then the flexure rigidity of this member in this direction will be more, because of the maximum members are available here to resist the wind load for the X direction. But in the Y direction less members are available, because there is no any element will come out in the Z direction as in the X direction is come. So in the Z direction flexure rigidity is less, so we have to assign only in z direction because the contact area is also be more for the z direction, because if we change our view, then you can see this is the area at which the wind load is applied, and for the x side, for the x direction, this is the area at which the wind load is applied. This is less area, so we don't have to send the wind load at here. So we have to assign in front view, means in z direction inside. So we change our view in isometry. So we have to use z with factor 1. And what is the height? We have to give the height, means range of 0. And maximum height we can take like 100, because above the 100 there is no member, so we can take it 100. And there is not any walls, so we have to use the open structure member. So click on add and then close. So you can see it is assigned. This is for the what? This is for plus z direction. So we use plus z and modify and then close. In same way, we can add the wind load for the minus z direction also. Wz minus z. Click on add and then close. For this, we have to use again wind load. Z direction with factor -1 is there, and height 100, open structure. Click on add and then close. If you want to see the loading diagram, so go to the loading and click on view loading diagram. But in by clicking on this, you not able to see. So you can, if you want to see, then double click on it and increase this factor. Like I take as 10,000, so you can see the arrows. You can change your view. So this is your direction due to the minus z wind load. Now remodify it. If you want to see this also, so by the same way, increase the zeros, 10 zeros. So you can see for the plus x direction, plus z direction, the arrows are in plus z direction. So wind is load applied in the plus z direction. So remodify it and close. So the loading is applied. Now we go to the analyze part. Click on define command, click on all, click on add and then close. Now perform this analysis, save and see what error will come and what warnings are created. There is no error and very less warnings. So warnings are 4. So we don't go to there. So now we go to post processing mode. Click on done, click on OK. So as I told in my last videos, how we check the nodes displacements and reactions and beam displacements. But one thing that I want to tell you, if you select any cross member like this member, because this is our truss member, so here you can see, but there is no load, it's come 0 0 0 0 0, so we don't take it, we take another member by zone. This member displacements are there. Now go to the beam results. Yeah, you can see here, click on this member. This member is 161, beam number 161. Here you can see there is no moment is generated and there is no shear force is generated in both the direction, because we use it as a truss member. So here you can see only one force, that is in fx direction. that may be in tensile and compressive, positive and negative sign are come in this respectively. So this thing I have to told because all the remaining things are same. The node displacement and the summary, how you can see the forces, you can see here all the forces. Now there is no plates, so we don't use this. But I want to tell you one interesting thing here. Wo I want to see the animations of the displacement. So I go to the loading, and in that load I use frequency model calculation consider. So you have to done click on frequency and model calculation, click on tick, right tick here and click on add, yes, and then close. So this is our model calculation requesting missing mass. So how it will be used, I will see you. So go to the post processing mode again, click on yes. First it will analyze. So analyze is done. Now go to the post processing mode, click on done. Okay. So we want to see the animations, how it will deflect. So click on animation, click on mode, decrease it and increase this value, click on apply. Okay. So you can see the deflected shape. The you can change your modes also. Mode to these are the modes. How and in this way this frame and these members will be deflect. You can see by change your mode numbers. So this is the interesting thing that you have to see, that in how much manner it will deflect. So go to the analytic modeling, and now our analysis complete and modeling and then post processing mode. So we go to the design part. So go to the design and click on steel and select our code IS 800 2007 LSD. First we have to define parameters. So I take only main important things like Fy limited. So it's our yield strength. So we can take 250 megapascal free. Click on add, and we can take here track also. How many details we want to print. Click on add and click on command. Check code we have to add. Member takeoff we have to add. Select we have to add, and last takeoff we have to add. And then assign these properties in assign to view to all the members. Check code. So code we have to assign to view. So these properties are assigned, and now go to the run analyze save. Click on yes. It will take time because there are a lot of members are present in our project. So here you can see there are 8 errors. So we have to see these errors also, that which errors are come. So this is our output file in which you can see our all the warnings, all the messages as well as all the errors. So zoom in. So I deselect these. Member design failed for member 91, 92 and 132, 151, 152. So there are, you can see 8 members are failed, and you can see also these members by clicking on select and click on attributes and property name. You can see the failed beams option is also available here. So click on this. So these members are failed. So what we do? We have to do to increase these member sizes. So go to property and click on section database, because we have to choose big members for these cross bracings. These are failed due to the same and small members. So Indian and angle section, we can take 20 to 200, 225, and then assign and click on yes, close. So now this property is assigned to this, but the material we have to take 355. It is, it can't be modified, so we have to delete it and create it again, because the material should be still 355 Newton per mm square. 355, assign, close. Now it will fine. Now go to the design, run analyze and save. Click on yes. So it will take some time. So as you can see, there is also 8 errors are also there. So we have to increase the member sizes again. I just check, 0 errors. Okay. So the error are eliminated, but warnings are not important. Errors are much more important, because if the error is present, model have some deficiency. So our project is complete. If you want to see your output file, as I told you in last videos, members number 5 for this member is this, and these details are coming. So you can check it by seeing this material. Now go to the geometry. The stat pro problem is that here is very difficulties if we assign the many of the properties to this. So you can also face these problems also. So if this problem will come, then right click and go to the labels and click on none and then apply. So these property labels will eliminate it and you can see your structure. If you want to check your property by double click on any beam, so click double click. You can check properties, shear bending forces, that all the things I have told in last lectures. This is the member ISSB 300H and this is our steel design. This is our pass and critical sections it will take and then close. So in this video I have told you that how we make our transmission tower and how we will design our transmission tower as per Indian standard course. So thanks to all.